Hello, and about survey search in a rotated subarray. And then the question is, there is an integer array nums sorted in ascending order. And I'm going to be highlighting keywords as I read these questions. Prior to passing to your function, nums is possibly rotated to an unknown pivot index such that the result of the array is this, right? For example, if it's rotated 3 times, you'll get that. Given the array nums after possible rotation and an integer target, return the index of target if it is in the number, or -1 if it is not in there. Basically, and you must write an algorithm in an O of n. So this is also a very key one. But these two things, a sorted array and O of n, O of log n, should let you know that it's basically asking you to use binary search. I'll go. Right. And any array I'm rotating 4 times. There will be a pivot point, like we see I'm rotating it 3 times. 0, 1, 2, 3. That's what is showing here. But that is not so important as the main question Angasan is a array, right? 4, 5, 6, 7, 0, 1, and a 2. Any amount target number. Say 0. Yes, find the index of the target number. And see, arrays indexes start from 0, 1, 2, 3, 4, 5, 6. Right? So they want you to find, say, 0 way. They want you to return the index of 4 right here. Say 0 anymore, just return -1. It means we didn't find it. Into as well number. Basically, because number like OSHA parts, right? Parts I'm arranging part in ascending order, and other parts also in ascending order. So it's not like straightforward sorted array. Will be to make a binary search, and then you just do it like that. Basically, but binary search, we have the left point and then the right point. The left point, which is equal to 0, and then the right point, which is equal to the length of the array -1, right? Will be divided, then you will get the midpoint, right? If you have the midpoint, you find the number at the midpoint. If the number is equal to the target that you are looking for, good for you. Then you just return that. You return midpoint. But if it's not there, you have to find out whether the midpoint is between the left and the midpoint, and I say it's between the right and the midpoint. So then you adjust it, right? If it's between the left and the midpoint, it means that the number is somewhere here. You reduce your search, and that is one of the key things about binary search algorithm. Instead of you search the whole thing, a chip, and then you search portion by portion until you narrow down to the point. But if say the number is say your right side, then you focus your search on this section, and then with more and more procedure, now chim. So you don't do the whole thing over and over again. You don't go through the whole process, but a chim said the way to reduce the time and then the amount of time or the best solve a question. But basically, it's a binary search with slight modifications. Be able to solve problem way. So let's go back to the code. Hopefully, I've touched on every point here. Basically, we want to return the index. So code no, and then let's look at it. But I think the key things you need to know about a question like this is binary search algo, right? And binary search has a time complexity of O log n and space complexity of O of 1. Right. So those are the most important things you need to know about solving the question. Once you have the algorithm, and if you have a sorted array and you are searching for something in a sorted array, use binary search. All right, let's go and implement the solution and see. So like I said earlier on, binary search first, let's build our left and right arrays. So left will be equal to 0, that's the first index, and then right will be equal to length of nums minus 1, right? Now, while left is less than or equal to right, we find the midpoint, right? So mid will be equal to left plus right over 2. And again, so you should double over here, it will give you an integer, it will not give you a decimal, because when we're solving this we just need a decimal. Now, like I said, if mid nums mid is equal to the target we are looking for, we just return mid because we they are everywhere. However, if nums left is less than or equal to nums mid, this one, it shows we are on the increasing side of the array, right? We are on that slope that is increasing. And if we are there, and if nums mid if nums left is if the target is between nums right and nums left, then we know right is equal to mid minus 1, right? Else left is equal to mid plus 1. Else if again target is between right and nums mid, equal to mid plus 1. Mid minus 1. And return minus 1. Right? So basically, this is a standard binary search algorithm with some minor modifications, because the question not suggests we do these modifications, right? First of all, we get the mid. If the mid index is equal to the target that we are looking for, then we just return the mid, right? Otherwise, if nums is less than mid, so this one I'd like you to refer to previous question, but there's also a binary search rotated one of the questions in there. It is similar. Anytime we have a number increasing like this, right? This portion is sorted. Any sorted numbers the first one is always less than the last one. Into this condition, and say we are still on the increasing side of this one. So if we are still here, if so long as left is still less than the mid, which happens to, if it happens to be here, it means that we are still in a sorted range, right? Into we are searching just this portion into the highest point right in the say now left and continue to be here, right? If it's in here. So basically, actually let's run this to see so it works. So basically, this is how you solve a question like this. It's more about figuring out how rotated arrays work, and also having a good understanding of binary search algorithms, and you will be very good to understand this question. All right, thank you. Bye bye.